The first time I walked into a freestall barn outside Berlin, Holmes County, Ohio, in the middle of August, I expected noise. I expected fan motors, I expected extension cords, thermostats, hot wiring, and that metallic hum you hear when a building is fighting summer with purchased power. What I found instead changed something. The air was moving, but nothing roared. It smelled like cut hay, pine dust, warm milk, and old lime. Light fell through the ridge in long white bands. I could hear swallows in the rafters. I could hear boots on packed dirt. I could hear a chain hit a stall gate. What I could not hear was a machine trying to rescue the room. I stood there for 11 minutes, looking for the expected thing. It was not there. No powered attic fan, no compressor, no switch bank, no wall of controls, just a roof line that looked ordinary from the road, a spinning ventilator over one section, and a building that felt cooler than it had any right to feel. That was the moment. Cold as iron, too. Short and brutal. I had been wrong about everything. Because the claim is not that one little roof fitting will run your whole life like a suburban fantasy. The claim is stranger. A roof, shaped correctly and opened correctly, can move heat, move moisture, and move air. Even harvest a steady trickle of useful electricity from pressure and wind you already paid for with the weather. Once I saw that, I stopped looking at roofs as covers. I started looking at them as engines. I went back in October. I went back again in February. Then in late May, when the air turns heavy and barns begin to hold heat like ovens. Every season, the same lesson waited for me over my head. Warm air rose. Wind found the high point. Moisture escaped. A small rotating head kept spinning when the ridge draft and the breeze lined up. No drama, no mystery, just physics. Old physics. I've been going back to Holmes County every season for 4 years, and every time I find something the building industry forgot on purpose. What I am going to show you is simple enough for a shed roof, serious enough for a farmhouse, and revealing enough to change how you think about power itself. In a published roof ventilator study, a 24-inch head fitted to an 18-watt direct current generator reached a striking result. Roughly 12 volts and 220 milliamps after step-up conversion at a wind speed of 5 meters per second. That sounds too small until you understand what it means. It means the roof is doing useful work before a single appliance turns on. And yes, this works, even if your house was built 50 years ago. Stay with me. Because what I found in Holmes County uses the same physics the Persians used to make desert cities livable 3,300 years ago. Most people hear a number like 12 volts and 220 milliamps and dismiss it in one breath. That is the mistake. You are thinking like a shopper, not a builder. A builder asks a different question. If the roof can already vent heat for free, what else has been oversized? Especially if that same motion keeps lights, sensors, radio, or battery backup alive. In the house, I mean. Because nobody counted the passive work first? That is where the money hides. The industry trains you to count only the machine. It trains you to price the compressor, the service plan, the fuel, the bigger breaker, the replacement cycle, and the emergency call. It does not train you to price the degree of attic heat you never let through the ceiling. It does not train you to count the moisture that leaves before mold gets a vote. It does not train you to value a roof opening because an opening cannot be financed at 14%. A simple shape cannot come back in 7 years and sell you another shape. Once you understand that, an impossible number stops sounding impossible. It becomes obvious. A passive roof system does not have to beat a utility company at scale. It only has to beat waste. It only has to reduce the pile of problems that your paid equipment is forced to solve afterward. Every degree kept out of the attic is cooling capacity you do not have to buy. Every hour of safe trickle charging is backup you do not have to rent. Every pound of moisture exhausted upward is rot you do not have to repair. The roof earns its keep before the meter even notices your name. The science is not exotic. Hot air rises, pressure moves from high to low. Wind accelerates over a roof surface and lowers pressure near the outlet. That pressure difference pulls heat and moisture upward the same way a chimney pulls smoke. Penn State Extension explains natural barn ventilation with one plain phrase: winds and buoyancy. In other words, breeze plus the chimney effect. That is all you need to understand before the whole trick opens up. The University of Central Florida says attic ventilation can reduce attic air and attic surface temperatures by convection. It also notes that natural ventilation can achieve similar attic heat flow reduction to power ventilators. The U.S. Department of Energy says 48% of all energy consumption in American homes is tied to cooling and heating. That means the battleground is not your lamp, it is the air above your ceiling. Win there first. Penn State's barn guidance gets even more specific when you look closely. It recommends a 4/12 to 6/12 roof pitch and continuous open ridges. It also recommends sidewall heights of 12 to 14 feet and a 2-inch ridge opening for every 10 feet of building width. It also recommends top sidewall openings equal to half the ridge opening, and it notes that a 3-foot overhang helps control rain and sun. Those are not decorative details, they are airflow decisions. Shape becomes function. Height becomes performance. Now think about what that means for an ordinary house. Your attic is usually the hottest, dumbest chamber in the building. It takes solar gain, stores it in sheathing, radiates it onto ducts, then presses it down toward your ceiling drywall. The University of Central Florida points out that a cooler attic reduces heat transfer through the ceiling and can keep ductwork cooler. That is not a style preference, that is operating cost. The roof is either your first defense or your first betrayal. Now add one moving head, the 2015 paper, the application of roof ventilator for electricity generation, mounted an 18-watt DC generator in a 24-inch roof ventilator. At 0.5 meters per second, it began making 0.2 to 0.3 volt. Above 2 meters per second, it produced about 3.5 volts. At 5 meters per second, with a step-up converter, it reached about 12 volts and 220 milliamps, enough for an LED lamp. Think about your car radiator fan. It does one job and demands power. This roof does two jobs at once. It vents the building and harvests a trickle from the motion. So here is the real comparison. You get useful ventilation and light-ready trickle output for 0 watts of purchased input. A conventional 120 to 150 watt powered attic fan only consumes. In building terms, that is an air exchange per purchased watt coefficient no plug-in fan can touch. The roof is using pressure you did not buy. The generator is catching motion you did not pay to create. That gap represents a massive market in equipment, service, and replacement every year. And that is why you have never heard of this. The proof gets uncomfortable when you leave the laboratory and walk into a real place. Mine came in Berlin, then again near Mount Hope, where I stood inside timber framing that held almost no mechanical noise. I felt the temperature change moving from the center aisle toward the ridgeline. I heard birds, hinges, and cattle. I did not hear a rescue machine. The air felt dry on my face. That detail matters. One afternoon, Eli told me something while we were looking up at the roofline. He tapped the post with 2 fingers. Then he said his grandfather taught him that hot air wants a clean path out, not a fight. He said they had used the same basic idea through 4 generations, changing hardware when it helped, never changing the principle. His people carried that habit from the Palatinate and Alsace into Pennsylvania, then into Ohio. Because a roof that breathes saves feed, timber, milk, and labor. That is why the old buildings still make sense when newer ones do not. The Amish did not learn this from a glossy trade ad. They learned it by watching barns sweat, then stop sweating when the openings were right. That knowledge never disappeared. It was written out of the manual. It was waiting. And if you want a paper trail, you can find it in the 1930 U.S. Department of Agriculture Bulletin, Ventilation of Farm Barns, and in later Penn State Extension guidance on natural ventilation. The old Amish builders understood this without software. They watched condensation show up on nails, rafters, and feed bins. They watched it disappear when the ridge breathed correctly. They watched hay keep better when hot, wet air escaped fast. They watched animals settle when air stopped stalling above them. They were not arguing with a theory. They were watching losses disappear in real time. That kind of evidence is hard to ignore unless your paycheck depends on ignoring it. I remember one late winter visit in Holmes County when the outside air was sharp enough to sting your nose. Inside the building, it was not warm in the soft modern sense. It was stable. That is different. I could feel the air moving upward even before I saw the light at the vent. Samuel showed me a section where newer metal had replaced older wood trim after a storm. He said the covering changes when it has to. The opening stays honest. That phrase stayed with me because it describes the whole philosophy. Replace hardware when it fails. Do not replace working principles because a catalog arrives. If you think this begins in Ohio, you are looking far too late. In Yazd, in Iran, wind catchers rose over rooftops long before anyone sold a compressor. The BBC's 2021 reporting on those structures notes that some of the earliest wind-catching technology comes from Egypt 3,300 years ago. It also notes that the wind catcher at Dawlatabad Garden stands 33 meters high. The openings face prevailing wind, funnel air downward, and let warmed air rise back out. Same principle, new language. The Romans reached the same answer from the opposite side of the year. Canterbury Museums explains that a hypocaust pushed hot air under floors. Then it moved through wall pipes before it exited at roof level. 2,000 years ago, they were already managing movement, buoyancy, and exit paths inside a building envelope. The Koreans did it with ondol floors. Medieval Germans did it with vented lofts and masonry heat. Every civilization that mastered extreme condition arrived at the same answer independently. The Amish never forgot. They carried it from Alsace to Pennsylvania and Ohio more than 280 years ago. They kept building it because it worked and because they never needed anyone's permission to do what made sense. Here is where wonder turns into anger. In 1922, Willis Carrier publicly debuted his centrifugal chiller at the Rivoli Theater in New York. It lowered the cost of large-scale air conditioning and protected a future built on compressors, coils, and controlled interiors. That future was worth fortunes. Every house or barn that solved airflow with shape, height, ridge opening, and wind threatened equipment sales. It also threatened installation labor, fuel demand, and replacement cycles. Then the mechanism locked in. William B. Rose's Oak Ridge National Laboratory history shows where the 1 to 300 attic ventilation requirement first appeared. In the January 1942 FHA document, Property Standards and Minimum Construction Requirements for Dwellings with no explanation or attribution. Later, the 1949 Housing and Home Finance Agency publication Condensation Control in Modern Buildings became the pivotal basis for future standards. Around the same era, ASHRAE's own history said the expansion of air conditioning in the 1930s made natural ventilation obsolete. That sentence tells you everything. Not because it failed, because compressors were profitable. And once codes and products took over the conversation, the language changed. Builders stopped talking about how a building exhales and started talking about what tonnage to install. Homeowners stopped asking where the heat wants to go and started asking what size unit they need. That sounds normal to you because you were raised inside the finished version of that sales pitch, but it is still a sales pitch. Nobody told you, not your builder, not your contractor, not the man who sold you a bigger unit. Look at who benefited. Sackett Wilhelms Lithographing and Publishing Company helped launch Carrier's first humidity control breakthrough in 1902. The Federal Housing Administration and later the Housing and Home Finance Agency turned ratios into rules. General Electric and Frigidaire pushed room cooling into the home market, and the Department of Energy notes that 43,000 room units were sold by 1947. Media needed climate control for paper and comfort. Regulators needed standardization. Industry needed volume. Their money moved in different channels, but it moved toward the same outcome. An entire field of knowledge disappeared from architecture schools, building codes, and everyday building judgment. Not because it failed, because it was not profitable. And the continuation is still happening in plain sight. On March 3rd, the International Code Council Board voted to eliminate governmental member voting. It removed them from the final determination of the International Energy Conservation Code. The Institute for Market Transformation says more than 75% of submitted comments oppose the move. It also states that the primary proponents were home builders and members of the fossil fuel industry. In 2022, Open Secrets reports that the Air Conditioning, Heating, and Refrigeration Institute spent $964,622 on federal lobbying. Nobody told you, not your builder, not your contractor, not the man who sold you a bigger unit. The U.S. HVAC systems market was estimated at $31.7148 billion in 2025. Every passive alternative installed is equipment that never gets sold, serviced, financed, and replaced. Now, if you already own a house and you're thinking this only applies to people with land, stay with me. Because this next part is specifically for you. You don't need to tear up your foundation, rip out your existing system, or buy equipment. You need a yard, a drill, a weekend. This is why I do not call the roof head a gadget. I call it a witness. The spinning cap shows you that pressure difference is still there. It shows you the roof still wants to do work. It shows you the atmosphere is moving energy across your building every hour, whether you cooperate or not. Once a small generator touches that shaft, the argument becomes visible. Now you are not just feeling the airflow, you are measuring it. You are watching weather become voltage. Small voltage, yes, honest voltage. Enough to break the spell. And if you decide to build one, start where failure is cheap. Put the first unit on a shed, workshop, or detached garage. Give it at least 80 to 160 square feet of roof area under the hottest section. Watch what happens at 2 p.m. Watch what happens after sunset when the thermal column weakens and the wind becomes the main driver. Log the battery voltage at noon, 4 p.m., and dawn for a week. You will learn more from 7 days of observation than from 7 hours of sales talk. Real knowledge works like that. It shows up, repeats itself, and asks whether you are finally ready to notice. If I were starting on an ordinary detached house, I would not begin with a fantasy. I would begin with a testable roofline. Pick the hottest side of the attic first, measure the span. If the building is 30 feet wide, use the Penn State rule as your mental benchmark. That means 2 inches of ridge opening for every 10 feet of width. That points you toward a 6-inch equivalent escape path across the top. On a retrofit, you may not cut a full ridge opening, but you can still think in those ratios. For the generator head, use a 24-inch aluminum roof turbine ventilator. Mount it as high as the framing allows, usually 18 to 24 inches below the ridge cap on a 4/12 to 6/12 roof. Flash it with EPDM, or a purpose-made aluminum roof flashing, not loose tar. Under that head, build a simple bracket from 1-inch aluminum angle. Hang an 18-watt DC motor used as a generator. Then connect it with a rubber belt or direct coupler sized for a 5/8 inch shaft. Run the output through a 12-volt step-up converter, a small blocking diode, and 16 AWG marine wire inside 1/2 inch schedule 40 PVC conduit. If you want storage, add a 12-volt 6-amp-hour LiFePO 4 battery in a ventilated box below the attic line. If you only want direct-use lighting, wire it to an LED strip or a low-draw emergency lamp and keep the circuit simple. A decent used turbine head runs $68 to $94. The generator runs $41 to $63. Flashing runs $26 to $39. Wire, converter, fuse, and conduit add $31 to $54. A small battery adds $79 to $119. You are still looking at roughly $245 to $369 before sealant and fasteners. The install is one Saturday morning if the decking is sound. Cut the opening carefully. Keep it round and true. Give the head at least 24 inches of clearance from rafters or stored boxes below. On a breezy 95-degree day, that setup will exhaust heat. It will also feed enough trickle power for LEDs, a radio, sensors, or battery topping. It will not run your clothes dryer. It will not fake being a utility plant, but it will do real work every hour the roof is hotter than the air column beneath it, or when the wind is moving across the cap. Quietly. One warning: proper flashing is not optional. Roofing tar alone causes leaks, rot, and sealing stains. If you want more airflow, pair the head with low intake openings at the eaves, and keep at least a 3-foot overhang or baffle path clear. Muslin dust screens help in dirty barns. Stainless screws help near salt air. Type S, hydrated lime wash on sun-blasted roof surfaces can cut heat gain further if the roofing material accepts it. Check the head once a year. Oil nothing if the bearing is sealed. Clear nests every spring. That is the maintenance. Your powered attic fan or small gasoline backup setup costs $280 to $850 to install. It costs $6 to $28 per month to run or maintain. It lasts 8 to 15 years before it ends up in a landfill. This costs $245 to $369 total. It lasts 15 to 20 years. Your choice. Everything I've covered across this channel is now in one place. Root cellar cooling, lime wash roof recovery, and gravity-fed water. Step by step, season by season, room by room, in the order the families actually use it. Link is in the description, but stay here, because what Eli built is the part nobody is talking about yet. What changed me was not the spinning metal, it was the insult. I had been taught to think usefulness began at the breaker panel. I had been trained to ignore what shape, height, shade, venting, and timing could do before a motor ever started. The Amish did not read this in a textbook. They figured it out the way all real knowledge gets discovered, by paying attention to what the air was already doing. And once you see that, you cannot unsee it. If you believe real knowledge has been pushed aside to protect someone else's profit, you already know what to do. Hit subscribe, not for me, for what comes next. Because this is not a channel. This is a quiet movement of people who have decided they're done being sold what they already own. I want to hear from you. Drop your state, your worst summer attic problem, or the monthly number you are tired of paying in the comments. I read every single one, and your answers decide what we cover next. Next week, I'll show you what a 1949 housing bulletin reveals about moisture and walls, and why older homes survived bad weather with less panic. The technique uses nothing but lime, wood fiber, and air. And the 1949 report proves federal housing engineers knew it 77 years before most builders mentioned it. You won't want to miss that one.